Alright, so did that make sense? Did you see the pattern? If you start at this umbrella, and now you take a rope segment that goes out to this umbrella, well, this umbrella did have an even number, but now it has an odd number of rope segments. And this umbrella over here did have an even number, but we've taken this matching bit away, so now it too has an odd number of rope segments, and we're kind of at this umbrella. But if it's got an odd number of rope segments left, then there has to be at least one segment that goes out of that umbrella. So let's follow that one. And now that umbrella's got an even number of rope segments again. But this umbrella up here has an odd number of rope segments. But if it has an odd number of rope segments, there's got to be one leading out. So I'm going to follow that one. And now that one there has an even number of rope segments again. And so we keep doing this, and eventually the only way that we can guarantee we're going to stop is by coming back to this one, the one that we started with. Anywhere else, we could always have an extra rope segment that we can come out of. So we have to be able to make a loop. Isn't that wonderful? Here's a warning though. If we've done that, it's quite possible that we'll end up in a situation like this, where we now have two different disconnected pieces. We could actually have lots of disconnected pieces, but the point is that the leftover stuff is not just one piece anymore. But here's something to notice. All of those leftover bits have less rope segments than we started with. So if we started with a configuration and we did some little loop and we took that loop out, then the configurations that we'd be left with would have less rope segments. And because we know that we can always do it with 2 or 3 or 1, we must be able to do all those other ones. And so we could just do them along the way. So like this. Start here. We know that we can remove that 3. So instead of just going ahead and removing that 3, start there, go down, now do a little side track, a little side journey. And we know we can do that side journey and then come back and now do another big side journey. We know that we can do that because that one has less. So if we know if we can do all the configurations with 1, 2, or 3 rope segments, then we must be able to do all the configurations with 4 rope segments. But if we can do all the configurations with 1, 2, 3, and 4 rope segments, this argument shows that we have to be able to do all the configurations with 5 rope segments. So we could use this argument to just keep building. This is called induction. So we know that if we had it for all of the 2s, then we could get it for the 3s. If we had it for all of the 2s and the 3s, then we could do it for the 4s, and 5s and 6s and 7s and 8s, and so on and so forth. And this kind of argument is called induction, and it's brilliant. So now you see it. If all of the umbrellas had an even number of rope segments attached to them, we're done. Alright, now if you were paying close attention, we did have another case. The other case was where all of them had an even number of rope segments attached to them, except for 2, and these 2 had an odd number of rope segments attached to them. Well, that means we've got to start here and end there. If you pay careful attention, you could probably nut that one out yourself now. Okay, so if that's the first time we've seen this contra-positive induction argument, your mind is probably melting. You've probably got goo coming out your ears. And that's okay. Because you know what? We're going to do something simpler again. Let's go back and look at your drawer of socks. Now, I don't know what your drawer of socks looks like, and I don't know what my drawer of socks looks like because I haven't looked in it for a while. But suppose we had 4 different kinds of socks. Suppose we had blue socks, red socks, pink socks, and grey socks. And suppose, without looking into our sock drawer, suppose we've got lots of each of them. I start pulling socks out. How many socks do I need to pull out in order to guarantee that I get at least one match? It's an interesting thought. Why don't you have a play with it? Here's the next interactive.